In this video, we're going to look at box plots. A box plot, or box and whisker diagram, allows us a quick and easy way to represent the distribution of data sets. The graph or diagram provides 5 key pieces of information and can be used to compare a number of different data sets on the same axis. From the box plot, we can read the lowest value, the highest value, the lower quartile, the median, and the upper quartile. This provides a snapshot and will allow us to find the range, the interquartile range, and compare the consistency of data sets. What we're going to do in this video is look at different scenarios where we could use or interpret box plots to find different values for our data sets. So let's start off and we will look at a typical question. We're told boys in class 10Z took on the girls in the class at a donut eating contest. The challenge was to eat 10 donuts. The data is summarised below. So this was the boys' times in minutes, this was the girls' times in minutes. Quickest time, now slowest time, lower quartile or Q1, median or Q2, and upper quartile, Q3. In the first part we need to draw box plots for each. In the second part we need to find the interquartile range for both. And then in the third we need to comment on the distributions in context. Okay, let's go ahead and do this. So what I'm going to do is start now with the boys. So what we can do now is put on the quickest time. Essentially a box plot is just 5 lines. So our first line is going to be the quickest time, and that is just here, and that is going to be now 3 minutes. The slowest time is going to be 20 minutes, and that will be just there. So 20 minutes. So straight away we can see the range from this box plot is 17. If we now look at the lower quartile, that's going to be 8 minutes. That'll go just here. We've got the median, which is the middle value. That's going to be now in here 10. We can place that just there. We've got the upper quartile, or Q3, and that's going to be 18. So this is what we have right here. We don't know how many people are in this particular data set, but what it's telling me now is that 75% of the boys are taking now 18 minutes or less. Half of the boys are taking 10 minutes or less, and then a quarter of the boys are taking 8 minutes or less. They're defined by the quartiles. So what we've got then, I'm assuming that this is to the nearest minute. We end up with this scenario right here. So we've got the lower quartile, the median, the upper quartile, and then the 2 end values. The quickest time and now the longest time. Later on in your studies you will see what we call outliers, and they will sit beyond that. But for now we'll just concern ourselves with this right here. Okay, let's go ahead now and draw one for the girls. So we've got now the quickest time for the girls is going to be 6 minutes. That's just there. The slowest time is 25 minutes, which is just here. We've got now a lower quartile of 16 minutes. So this is telling me now only 25% of the girls finished in 16 minutes or less. 18, that is the median. So 50% of the girls finished now in 18 minutes or less. And then the upper quartile will be 20. So 3/4 of the girls now finish this in 20 minutes or less. We connect up our box, hence why it's called a box, and then the whiskers from here. So that's what we've got. And we need to label these up, and I'll write on here boys and girls. So let's just put that in place. Let's grab that and make it look slightly neater. So this now is our box plot, or box and whisker plot. So writing on here now, this one is going to be the boys. So from here we can say boys, and this one right here is going to be the girls. So if this was now a large data set, we can see from here now for the girls that 25% of them took between 6 and 16 minutes. We can see now that 50% took between 6 and 18. We can see that 75% took between 6 and 20. We can see the range of times is going to be 19 minutes. Okay, let's now look at the IQR. The IQR is the interquartile range, and that considers now the range of the middle 50% of people, or the middle 50%, or half I should say, of data observations. It just means now that we're taking out these potentially extreme values here. So what we can say then is for the boys, we will find the IQR. So what we can say then, IQR is now going to be upper quartile UQ minus LQ. So in the boys' case, what we're going to have then is 18 minus 8, which is going to give me 10 minutes. So this is telling me now that 50% of boys in the middle had a range of 10 minutes difference, or essentially from 8 to 18 to eat these 10 donuts. For girls, what we've got then is the upper quartile minus lower quartile. Upper quartile is 20, lower quartile is 16, and that's going to give me 4 minutes. So what does this say? This says now, comparing these two, that the girls were more consistent. They were slower. The median time it took for the boys to eat 10 donuts was 10 minutes, whilst it was 18 for the girls. Yet the girls were more consistent. 50% of them took now a maximum difference of 4 minutes. They took between 16 and 20 minutes, and that's the middle 50%. Yet the middle 50% of the boys took a 10-minute difference. So what we can say is the girls were more consistent. Now, if I took this information away, and let's just scribble this out, we could now actually use the box plot to comment on the distribution. So if we just ignore what we've got here now, we can go ahead and look and make comparisons. Later on in the video, we will make comparisons given just now box plots. So let's get shot of the data and let's look at them. We can say the quickest person was a boy at 3 minutes to eat the 10 donuts. The slowest person was a girl, and that took them 25 minutes. The median time for a girl to eat the 10 donuts was 18 minutes. The median time for boys to eat the 10 donuts was 10 minutes. 25% of boys took less than, or 8 minutes or less to eat this. 50% of boys took 10 minutes or less. 75% of boys took 18 minutes or less, and then 100% of the boys had been finished now in 20 minutes or less. So we could say that 75% of the boys completed this at the same time now as 50% of the girls. We can say now that from here that 25% of the girls completed the eating in 16 minutes or less, half of them in 18 minutes or less, 75% in 20 minutes or less, and all of them in 25 minutes or less. So some comparisons, we can see the boys were less consistent but generally quicker as the median time was lower. The girls were more consistent yet generally slower. The boys had now the shortest time and the girls had the longest time. And when you're answering these questions in exams, they must be in context. So you must state now it was 10 donuts, taken time to eat 10 donuts in minutes. The median time for the boys to eat 10 donuts was 10 minutes. The median time for girls to eat the 10 donuts was 18 minutes. Don't just put the median is higher than the other one. Okay, so that's now drawing the box plot. It says the following scores were achieved in a test by members of class 11A. So we've got now 6, 3, 9, 8, 4, 10, 8, 4, 15, 8 and 10. We need to draw a box plot from the information, we need to state the IQR, and we need to make 2 statements about the data in context. Okay, first thing I'm going to do is put this in order. So what I'm going to do now, let's just go ahead and do that. We're going to put this in order. So I'm going to have now 3, and we'll write this just here. Then we're going to have 4, and we're going to have 4. So let's go ahead, write 4 and 4. Then the next one we've got is going to be 6. We've got our 6. Then we've got 3 8s, 8, 8 and 8, and we'll put those there, 8, 8, and then the other 8. We've got a 9, we've got 2 10s and a 15. So 9, 2 10s and a 15. So let's go ahead and do these. So 9, 2 10s and a 15. So these are now in order. What I want from here now is the lower quartile, the median and the upper quartile, and the 2 end values. Now, by the looks of this here, we've got an odd set of numbers, and this is discrete data. So we can pick up the quartiles quite easily from this. If we've got an even set of numbers, the general convention is you do n plus 1. So for the lower quartile, 1/4 of n plus 1. For the median, 1/2 of n plus 1. For the upper quartile, 3/4 of n plus 1. So this now is the lowest score. This is the highest score. So straight away we can simply add those to the box plot. So if we consider now what we're going to have, the lowest score is going to be just here, and that is 3. The highest score is going to be just here, which is going to be 15. Let's now consider the quartiles. So we can see now that the lower quartile is going to be 4. That's the lower quartile. From this we can see now that the median, if we consider, is going to be on here 8, and then we can see from here that the upper quartile is going to be 10. So if you want to work that out, you can just go a quarter of the way in, a half the way in, 3/4 of the way in. This is quite nice in the way that it's fallen, again, because we have an odd number of pieces of data. So let's go ahead and do that. So we're going to have now the lower quartile, which is going to be just here. We're going to have the median, which is going to be just here. And we can have now the upper quartile, which is going to be just here. So that's what we end up with, and we simply connect this up, and then we have our box plot. So our box plot is going to look something like so, and there are the whiskers. So box and whisker diagram, or box plot. So let's have a look at what we've got now. From here we can study now the IQR. The IQR is going to be now, so let's write this here, IQR is going to be now the upper quartile, it's UQ upper quartile minus lower quartile, or if you like, Q3 minus Q1. So we can see that that's going to be 10 minus 4, so we can say that that's going to be 6. So the interquartile range is now 6 marks. Okay, let's make some statements about the data in context. We can say only 25% of students scored 4 or less. Only 50% of students scored 8 or less. 75% of students scored 10 or less. And we can say now that 100% of students scored 15 or less. The maximum mark was 3. Minimum mark was 3, the maximum mark was 15. The median mark achieved, or median score achieved in the exam was 8. We can see that these scores are fairly inconsistent given the data set. So for example, and I'll just jot it here, if I had now my interquartile range just here, so the middle 50%, what this would say, and we could put the median in the middle if we liked, we could say that these were more consistent and they had a higher median score. So just looking about this now, we need to, if this is in context, talk about now the score relative to the class. Don't just say the median. Say the median score of now the members of 11A was 8 marks. So there we go. Let's just get rid of that little part there. So we can say now from here that we've got generally inconsistent results with now this spread right here. We've got quite a large spread. Now the range is going to be 12, and again that's a large spread of scores given the relatively small values on these. When you have another class to compare them with, it's often easier to make direct comparisons. Okay, let's move on. We're told the box plots below show the end of year test scores out of 20 of the Year 9 top set in maths over 3 years. So Year 1, Year 2, Year 3. The classes were taught by 3 different teachers. Compare the data and make 3 statements on your findings. Okay, so let's look at these right here. We can see quite clearly that this one here is giving us the most consistent scores. Whilst they're sitting in a range from 6 to 11, the pupils in this particular set were more consistent. So this might tell us about the ability of this particular year group. It might tell us that they're all very similar, but they're not high flyers. It could tell us that the teacher only taught certain topics and they did okay at those, but nobody really went to the top end and nobody really went to the low end because they did lots of the same thing. So I'm making 3 statements. These are just now my observations and what might have led to this. So we can say that now in Year 3 we had an interquartile range now of 2, that's 10 minus 8. The median score was 9. So if we look at Year 2 has the highest median score for the pupils now, and that was 12. So from here we can see again in year 2 we had the highest scorer. Now that highest scorer was significantly higher than the others. That might be down to the natural ability of the pupil, or it might be down to the teacher. If we consider though in year 2 these were the least consistent. They're the least consistent as the middle 50% now are spread over 8 marks. So the interquartile range for year 2 was 8, which shows quite a big spread. So down at the bottom end, now there's 13 marks difference between the top achiever and the lowest achiever. Right here now, these are fairly consistent in comparison to the year 2, but at the same time they're lower. This has the lowest median score. So if we were to compare purely based on median, which you might argue is not fair, this would give us now that the median score in year 1 was 6 out of 20, which is disappointing. We can see that someone got 1 out of 20 and someone now got 10. 10 was the maximum score. 75% now of the students were scoring now 8 or less, yet only 25% of the students in year 3 scored 8 or less. So these are the comparisons that we can make. If we consider now here 50% of students in year 2 scored 12 or less, therefore 50% scored 12 or more. None in year 3 scored 12 or more, and none in year 1 scored 12 or more. So 50% of the students in year 2 scored higher marks than the highest scorer in year 1 and year 3. Let's have a look at some of the other things from here. We can see now that the lowest scorer here now in year 2, there were more than 25% of people in year 1 getting a lower score. So there are some comparisons that we can make in context. You need to state now that these, in relative to each other, are now. So for example, if I just said this has got the highest median, we want the highest median score now out of 20 over now the 3 years. So look at things to make statements on. Look at the highest and lowest. Look at the spread of data. So the consistency. Look at the median score. These are the kind of comparisons that you will need to make. So make the statements now on your findings. Why might they happen? Well, I could say now that generally these were weaker students. I could say generally we had the stronger students in this one, but there was a spread or a mix of ability. Here I could say they were very similar, but not the highest achievers, or this could be down to the teaching. This could be down to the teaching, or this could be down to the teaching. These 3 cohorts might be the same. So any intelligent statement based on the information you're given would suffice. Okay, let's go ahead now and look at when we have continuous data. So this information is put in a cumulative frequency curve and we can estimate the medians. Given that it is now from group data, we can estimate the medians. So what I'm going to do is now draw a box plot from a cumulative frequency curve when we're dealing with group data. So what we can see here now is we've got 120 observations and we've got test scores up to 100. So what I'm going to do is find the quartiles. Now when we're estimating, it's as crude as simply dividing this into 4. So what I'm going to do from here is go across and divide this into 4. So if I just now find 90, 90 looks to be about there, okay? What I'm going to do is read down. So this is now going to be the upper quartile, okay? So all I've done is taken off now 30 from that, and I'm going to read that, okay? Now if I just place that down like so, I'm now going to take the median. The median will come now on the 60th observation. So if you're asked for the median now, an estimate for the median isn't 60. It's now observed on the 60th value, which looks to be, give or take, what's that, 52? And then now what I want is the lower quartile. So lower quartile will be approximately there. Again, this is only as accurate as I can see on here. And of course, if it's group data, it's an estimate. Now, to complete our box plot, generally now we would have the end values, and the end values in a group data will just be given by the 0 and now let's just put that on, and now the 100. Because it's group data, we don't actually have a highest and lowest score. So all I'm going to do is draw the box plot of this. So grabbing this up now, this is going to look something like so. So we're going to have now the interquartile range. So from here we can see the interquartile range will look something like so. We've got now, let's just extend that slightly, it's a touch wonky. Let's go back and drop that down. So you will obviously on graph paper do this a lot neater. That is the median value just there, or an estimate for it. These for completeness are added, yet we don't know what they are as it's group data. So for example, if this end group was now from 80 to 100 or from 90 to 100, they might all be observed at the lower end. They might all be observed at the top end. It's group data, so we can't tell, but for completeness, this is what we do. So what we're going to have, if we look at this is going to be the upper quartile, or Q3. So UQ, upper quartile, median, or Q2, lower quartile, just here, or Q1. So let's just put that as Q1, Q2, and Q3. Usually at GCSE, you've got now upper quartile, median, and lower quartile. So that's drawing a box plot of now a cumulative frequency curve where we've got now group data. So there we go, box plots. Hopefully that's given you enough information to start with. I may do some more videos looking at the use of box plots and working again with continuous and discrete data on them. But the take-home points are you're going to have 5 different pieces of information. The lowest value, the lower quartile, the median, the upper quartile, and the highest value.